So in the engineering field, a very important term that we want to study today is stress. Okay, stress, it is defined as the force by the area. Okay, force which is applied. Suppose if I'm going to consider a bar, the bar is like this and it is having a length L and the cross section I'm going to consider this as a D, means it's a diameter. So if I'm applying a force at the end of this bar, so there will be a response within the material. That internal forces, because of the applied external force is generated, that will be the response. Okay, when we are defining the stress will be the force divided by the area. The force, it is the internal force which is because of the applied external force, and then it is measured in terms of Newton. So area, it will be the area of the cross section. Suppose this force, if I'm drawing like this, if it is a rectangular cross section, the load will be acting like this. So I will define this along two coordinates x as well as along this direction as y. The force will be acting along x direction. So this force F is acting on this cross section. When we are going to find out what is the stress, in that case we have to take the area, this area which is normal to the direction of the force, which is normal. So you cannot consider this as an area or this as an area. No, it is the area which is normal to this force. So this will be area. If it is, say here, if it is a circular one, I will write the area as pi d square by 4. So d, it is a diameter, and then it is measured in terms of mm. So area, definitely it is measured in mm square. So that if I am going to consider the rectangle one, so area for the rectangle is, it is, this is, I will take as B, and this I will consider as D. So here the area of the cross section for the rectangle B into D. Always remember that the load, the area what we consider, it is normal to the applied force. Okay, and then if it is a hollow one, okay, if it is a circular hollow, if it is like this, so it is having an internal diameter as di, sorry, and external diameter as d0. In this case, the area is equal to pi d square minus di square by 4. These are the major three areas that we are going to consider to solve the problems. So definitely, if I am going to substitute, see here, sigma is equal to the resistive force within the material divided by the area. Area can be anything. It is a circular, rectangle, hollow. We will consider any one of this. If the problem is given rectangle, then you have to use this equation. If it is given a hollow, and you can use this equation. Okay, next, this is, I am going to, first of all, the unit of the force, we know that it is measured in Newton, and then area, the unit is, it is mm square. So the unit of this is sigma. The unit of stress is Newton per mm square. Newton per mm square. So this is only a one portion. If it is one of a stepped bar, if it is like this, here we have two portions. L1, I will take this as 1 and this one as 2. So same way I will define the length for this portion as L1 and for this portion as L2. And same manner I will consider this as a diameter. So here it is a D1 and here it is D2. So phi means it is diameter. Okay. So load is acting on that, like here. Load is acting. Some force is acting on that. So here there are two portions. Means this force is common to both the portion. So you have to calculate the stress for each of the portion separately, because here this is the diameter is different and this diameter is different. So we will first consider the sigma 1. Sigma 1 is equal to, first area will be, force will be the same, force by the area 1. Okay, second equation that I am going to write it for the second portion is sigma 2 is equal to F, as usual same, because of only one force is acting. So the area is, again here it is A2. So A1, what is the A1 here? It is a circular one. So we will write this as pi d square by 4. Here I have to write it as d1. This substitution, you have to calculate the area and substitute in this equation. And same as well as here it is A2. A2 is pi, okay, d2 square by 4. d2 square by 4. So this is the way, and then find out the area A2 and substitute in this equation. So I think you have understand that the force on this is a stepped bar, that if a single force is acting on the bar, in that case this force will commonly used to find out the stresses for each of the portion separately. That can be calculated by using the equation by F by area. The area will be of the each portion that you have to find out depending upon the what the cross section it is given in the problem.